Welcome everyone, and we appreciate you joining this session about the 5G MEC overview and the forecast. I'm Dave Bolan, and I'm the industry analyst at Dell'Oro Group for the 5G MEC as well as the mobile core network reports that we do for our research here at Dell'Oro Group. What I want to cover today is what are the industrial drivers for 5G MEC and what applications are driving that, as well as the technology uses, and then what I think the most important part of the presentation, some real world examples that are already out there. And then we'll briefly touch on the 5-year forecast. The real driver that we see today is lower latency. That's the primary driver that people have for the 5G MEC. There's applications that the 5G technology has been designed to attack with the lower latency. Another driver is data sovereignty. Enterprises that might want to use 5G MEC in their factories want to keep the data maybe on their premises, and the 5G MEC architecture allows you to put a 5G MEC system right inside an enterprise's campus. And then last but not least is optimized backhaul. From a service provider perspective, they can save money on backhaul costs and not moving all the data back to the central data center. And when we get into 8K video now, that is possible to 16K video. The amount of data that's going to be generated over time is going to just explode, and it might not even be practical to backhaul all the data in the future. So 5G MEC for the service provider is a driver. Lower latency for the end user, it's like a symbiotic relationship. It's a win-win relationship that exists, I think, for the 5G MEC opportunity. As we know, there's a lot of applications out there for that have been publicized, and here's just a brief list of them. But one that I just want to note is online gaming. It's considered by some as the killer app that if you solve the problem for doing online gaming, because they will pay for latency, and that's one reason you want to tackle online gaming first, is once you solve that problem, you solve a lot of problems in implementing and providing the performance. A lot of the other opportunities here are on this page that can take advantage of that MEC architecture that it would deploy for online gaming. What's really driving this is the need for facial recognition, visual inspection technologies for monitoring the production line to see if everything is working properly, or video surveillance or drone video surveillance. Remote operations, like in a crane, you want to remote, instead of being in the crane, be down on the ground in a room, remotely operating the crane, or a surgeon remotely using a remote robotics to do a surgery. Time-sensitive networking. If we want to get into replacing Ethernet wires in a factory, time-sensitive networking requires extreme ultra latency. But most arguably the most latency intensive requirement for low latency is the vehicle to X or vehicle to everything autonomous driving applications. And we need that obviously for safety. But these applications aren't necessarily driving MEC technology unless it's for real-time communications. I can have facial recognition, but how fast do I have to have it? Well, if I have to have it real-time, then you need the 5G MEC with low latency. And so that's the same for your virtual reality, artificial, augmented reality, and mixed reality and extended reality as well. When we get into analytics with artificial intelligence and machine learning, we need that. If we need that in real time for video and data analytics, another need to have 5G MEC. The use cases that are already up and running in places around the world, just a few of them that we'll touch on. We can't touch on them all, but everybody around the world has been working on this, and it's been nice to see. So for gaming, Tencent has been working with China Mobile with the Tencent Gaming Cloud platform to produce 4K video at 60 frames per second with 10 to 20 millisecond latency. Tencent is very focused on this. They are the largest online gaming company in the world with their League of Legends and many other properties that they own. And they've done this first in the Guangzhou, China, city of Guangzhou in China. Smart ports has been another popular application with remote gantry, crane operations with artificial intelligence on the video analytics with 360-degree cameras, and this makes the operators reportedly twice as efficient and in the controlled environment when they're instead of sitting up on the crane. Also, smart ports can take advantage of automated logistics with unmanned trucks. The truck can be dropped off at the entrance of the port, and drivers can pick them up at the other end of the port. This has been done with China Mobile in the largest port in the world in Zhejiang. Vehicle to everything, another popular application that's written about a lot. The government of Germany has funded a 3-year study for MEC to see how MEC can be implemented and obviously be done safely. This has been spearheaded by Bosch, and the other German auto manufacturers have also participated in this study. It's been a team effort, but spearheaded primarily by Bosch. It is in the Germany, where this test network is up and running. And I like Bosch's conclusion. A bird's eye view is better than a worm's eye view, because the conclusion of the study is to make MEC safe in an urban canyon, we need to have the sensing technology, cameras or whatever it is, on streetlights, because the car is not going to be able to sense a car coming around the corner in an urban canyon. So, and the other thing that came out of the study is that 4G was pretty good, but not quite good enough. So for ultimate reliability and ultimate safety, 5G MEC is required, and especially on the streetlights in urban canyons. Smart grids is another popular application. In this particular example, it's substation power distribution sensing done by China Telecom, and the end user was the State Grid of Corporation of China, and done in the Qingdao, China area. We hear a lot about smart healthcare as well. In this example, it's 3D image rendering by China Unicom, and the end user is the Xinjiang County People's Hospital. It's a network. It's an ultra reliability, low latency network for the whole county hospital system. And doctors anywhere can get their 3D rendering from any hospital if they don't happen to be in that particular hospital location at that time. So it's providing more productivity for the doctors to be able to diagnose remotely. Industry 4.0, smart manufacturing that we hear a lot about. There's actually one factory that has completely digitally transformed, all 5G MEC with automated guided vehicles also on the property. This was done with Vodafone, and the end user is Ego Mobile in Germany, Aachen, Germany. And as I mentioned, everything in the factory has been digitized, a total digital transformation. But I just want to note that this particular factory does not use robotics, so you won't get the application for robotics, but they digitized all their tools, the sensing, video analytics, all that kind of stuff is being performed in this smart factory. Looking now at some service provider deployment scenarios, SK Telecom was the world's first nationwide MEC deployment with 11 MEC systems deployed around South Korea, giving every subscriber within 100 kilometers of a MEC system, giving them great latency for their 5G non-standalone network that was deployed last year. And this was primarily targeted at the gaming community. But as I mentioned, once you've targeted that and implemented that and you have the lower latency, other applications can take advantage of that. And you can see there on the left some of the other applications that SK Telecom is targeting. And there's more, but this is just a brief list. Just to give you an idea of the performance of the network, their round-trip time delay is 30 to 100 milliseconds, and their goal is to get that to 10 milliseconds with their next generation 5G standalone networks and probably more deployment of MEC nodes to provide a higher density and lower distances. The world's largest nationwide MEC deployment is at China Mobile. China Mobile's has a two-core strategy. They have a core for the B2C market and the B2B market. And their topology was first tackling the province level and the city level. And they already have 31 sites for all 31 provinces have a MEC node. And at the city level, they've got up to 295 sites done, up and running with MEC performance. And you can see there the latency greater than 20 milliseconds in the province and 10 to 20 milliseconds at the city level. And you can see where China Mobile is going in the future at the county level to get down to around 10 milliseconds, get down to the RAN site level or the enterprise site level and get under 10 milliseconds in latency. At Dell'Oro Group, the way we look at the MEC 5G MEC opportunity is we forecast the NFVI, which is the servers that run all the MEC applications, and the UPF software. And we forecast that to be greater than $10 billion over the next 5 years. This does not include the software that would run on those servers, but the servers are sized to include this, the management and orchestration software that's required, in the API software for facial recognition, augmented reality, etc. All the things that we've talked about. And I don't think it's any surprise that the Asia Pacific region is the largest region forecasted. They're going to get off to a little bit head start here, as we just saw how the big deployment that China Mobile has. So the opportunity is there for all 4 regions. Caribbean and Latin America obviously being a little bit slower, but they already have some trials going on. So to wrap it up, there's compelling drivers for the industry and communication service providers. As I mentioned, there's that symbiotic relationship for lower latency and reduced backhaul costs. And there's tons and tons, or a plethora of use cases that are out there. And we just briefly touched on a few and listed a few of them. And this gives the communication service providers an opportunity to generate new revenues. And I think they all need to do that. And the takeaway I want the communication service providers in the audience to take away with them is have an aggressive MEC deployment strategy. This will give you a competitive advantage in the marketplace. Be first to market in your market with a 5G MEC. Get your 5G innovation labs up and running so the enterprises know that you're serious about 5G MEC, and make plans now to start deploying your 5G MEC if you haven't already done that. Thank you for your time, and I'll be around for questions later.